Okay, on page 16, these are all angles where you're trying to find the angle. So there's that extra step, which for everyone's calculator, they either have to hit the second function or the shift function. So it was practice to make sure you get good at that, because usually the problem students have is with the calculator, learning the correct order of things, right? And the easiest way to do it. So, but just like everything else, most trig questions are like 3 marks. 1 is for labeling. The second mark is for figuring out which ratio you're using, sine, cos, tan. And then the third mark's for getting the actual answer. So you can get 2 out of 3 and never get, you can get 2 out of 3 on every question and get like the whole test wrong, right? Hopefully that won't happen. Okay, hopefully by now you're starting to feel a little more confident with what you're doing. So if this is the angle that I'm looking for in A, what's this side called at the bottom here? Yeah, it's touching it. Because it's touching it or forming the angle, it's either the adjacent or the hypotenuse. And this one is the hypotenuse, so this one has to be the adjacent. So you just remember that the opposite side is the only one that doesn't actually come in contact with the angle. So opposite has to be over here. We're not using opposite this time. So which ratio has adjacent and hypotenuse in it? Cosine, yep. So I'm just going to make my little formula pyramid here, CAH. And I'm looking for the cosine. So all I'm going to do is go A divided by H. So I just go 4 divided by 5. And what I'm looking for is actually the inverse cosine of that. That's how I would write the notation for it. Don't worry, you don't have to write it that way. But I like writing it like that because I can actually do it that way in my calculator. I can go second cos to get that inverse cos function. And then I can open a bracket and go 4 divided by 5. If you're going to do it this way, make sure you use those brackets, because otherwise your calculator will try to do the inverse cos of just the first number and it'll give an error. Okay. And then I'm just going to hit equals, and there it is, 37 degrees. Anybody else get 37? Yeah. And with, it says here, round answers to the nearest degrees. You're either going to go up to 37 or down to 36. Because it's closer to 37, we'll call it 30. Okay. Okay, next one. This is the angle. If I go across from it, that's going to be the opposite. This side here is right beside the angle. So it's either going to be the adjacent or the hypotenuse. Which one is it? It's the adjacent, right? Yeah. Because the hypotenuse is the longest, and it's always across from this one. Okay, so which one of those things, ratios, has opposite and adjacent in it? Tan. Which one goes on top? Opposite, yeah. So I'm just going to do the inverse tan of 11 divided by 9. And I get 51 degrees is angle theta. Hello? Come on in. We're just doing solutions for page 16. Okay, so this side here is your hypotenuse. The side across from it is your opposite. Which one of the ratios has opposite and hypotenuse in it?
Sine.
Sine. So I'm going to do the inverse sine of 8 divided by 19. And 25? Yeah, 25 degrees is theta. So the first one was 37, then 51, then 25. Okay. This one here, if this is my angle, what's the 65? What's that side called? Opposite. And the 56 is the adjacent. O and A is tangent. So I do the inverse tangent of 65 over 56. Yeah. 49 it looks like. Yeah, 49. So with those tangent questions, it's pretty common for students to mix up which one goes on top. If I had accidentally done, let's say that I'd made a mistake and I accidentally punched in the inverse tan of 56 over 65, that would be 41. Where is the 41 in this triangle? If I did 56 divided by 65, which angle am I solving for? Yeah, that'd be the one at the top. What's that? No, I'm just saying that if I made the mistake of punching in 56 divided by 65 instead of 65 over 56, the calculator would spit out an angle for me, but it would be this angle up here. This is 41. So the good news about sine and cosine ones, if you mess them up, they'll give you an error, like if you put the wrong number on the top. But tangent will give you an answer. It'll just give you the answer for the other angle. So you got to be careful that you make sure you put the correct one on top. With the sine and cosine ones, the top number is always the smaller number, right? But with tangent, that's not the case. Okay, for E, here's your angle. This side over here is called your opposite, and the 47 is the hypotenuse, so that's sine. The inverse sine of 27 over 47. 35 degrees, you got it. Okay, just going to speed up these a little bit faster because they're all the same. This is your opposite. This is your hypotenuse. So that's an inverse sine. And that's going to be 18 over 3. 33 degrees, yep. Okay, this one is going to be opposite over hypotenuse. So that's going to be an inverse sine again. 13 over 15. 60 degrees is correct for theta. This one is going to be opposite over adjacent, which is a tangent question. So opposite's 23, adjacent's 29. Which is 38 degrees, yep. Next one, 54 is your hypotenuse, 42 is your adjacent. So that's a cosine one. You're going to get inverse cosine of 42 divided by 54.
39.
Yeah, 39 rounded. So 39 degrees. And the last one on this page, that's your opposite. That's your hypotenuse. So that's an inverse sine of 38 over 57.
42 degrees.
Rounds to 42. Okay, there you go. So it's a fair amount of practice finding the missing angle, solving for the missing angle. And if you're not getting those, make sure you come up and see me so I can watch you do it. It means that you're not It's how your calculator works. For some people, it's a lot of steps in their calculator. For others, it's faster. Okay, and then you're supposed to start assignment 3. And assignment 3 is a mix-up, right? Some of the questions you're finding an angle, some of them you're finding a side. So again, this trigonometry stuff, it's all about just getting a lot of practice. Get faster at it, right? That's how I was able to like give you a sheet and just quickly get the answers, because I've done them so many times. Okay, so this 23 over here is your opposite. 17 is your adjacent. So I'm finding an angle, so I'm doing the inverse tangent of 23 over 17. You got 54? Yeah, rounds up to 54, and that's theta, 54 degrees. Okay, the next one, we already know the angle. So we're trying to find a side. X is the hypotenuse, and 19 is the adjacent. Which ratio has A and H in it? Cos. Okay, I'll use a pyramid here. CAH. I'm trying to find the H, so I'll cross that off. So it looks like it's divide. So 19 divided by the cosine of 62. And that will give me the hypotenuse. So 19 divided by the cosine of 62. Yeah, and because it says solve for x to 2 decimal places, I'll go 40.47, I guess.
47?
Yeah. 40.47 meters is x.
What about 40.5?
40.5 is correct, but it says in the starting here, solve for x to 2 decimal places. So we'll try to make sure we have 2 numbers after the decimal. Yeah. If it was a test and that was specified, you would just lose a half mark once. Just for the whole, you'd only lose that half mark once for the whole test, just for not following the rule. I wouldn't dock you every time if you did that just once. It wouldn't hurt you badly on a test. Okay. I'm more interested that you know how to do the trig. And if you got 40.5, clearly you knew how to do the trig. So this one here is going to be your opposite, and that one is your hypotenuse. So because we're finding an angle, we're doing the inverse sine of 35 over 57. In this case, we've already got the long side, so I'm actually going to be using c squared minus b squared equals a squared. All I need to remember is that I go 29 squared minus the shorter side, and that will give me the missing side squared. Okay, let's find out what that is. And then I got to hit square root, right? Positive square root. If I do the square root of 29 squared minus 14 squared, and I square root it, I get 25 rounding it up, 40 equals x. I guess that's in centimeters. Anybody else get that? 25.40? Okay, but if you look to the right of the 9, there's a 6, which means go up. So turn 39 into 40. So you did it right. If it was a 3-mark question, you'd get 2.5 because of a rounding error. But I would only take off that half mark once in the whole, so it wouldn't be a big deal. Okay, next one, finding the angle. That's adjacent, hypotenuse, so that's cosine. The inverse cosine of 5 over 13 is 67, yep. Okay, this one is adjacent and hypotenuse again. So it looks like it's another inverse cosine. 863 or 978. $28 degrees. Yes? Okay. For G, trying to find this side over here, which is the what side? Opposite, yep. And the 61 is the hypotenuse, so I'm going to be using sine. And I'm trying to find the opposite, so I need to multiply. The sine of 72 degrees times 61 equals 58.01, I guess that's millimeters, is x. Okay, this one, that's the opposite and that's the adjacent. So it looks like I'm finding the inverse tangent of 685 divided by 500. Round it up, 54, yep. 54 degrees is theta. Okay, this one here, that's the hypotenuse, and that's the opposite, so it looks like a sine question. We're trying to find the hypotenuse, which means I'm dividing. So 87 divided by the sine of 23. Which is 222.66 feet. Anybody else get that? 222.66? Same thing, sure. Yep. Good. Okay, doing them a little bit quicker there because, you know, we've gone through the process a bunch of times. We'll slow down a bit as we get to the word problems. Okay? So, because all these trig questions tend to be kind of 3 marks, 1 for, you know, any kind of labeling, 2 for identification of which ratio, and 3 for getting the right answer. Some of the word problems would be like an extra step because you got to make your triangle. So they'd usually be 3 or 4 marks. Okay, this one actually has a triangle for you. Oh, well, that's no fun. They've drawn triangles for you all the way through. They're more fun if you have to draw your own triangle. Okay. Okay, number 2. Around noon each day, the shadow of the Calgary Tower measures 84 meters. The angle of elevation of the sun. Now this expression, angle of elevation, just means from the horizontal up, like from the ground looking up. We call that an angle of elevation. Elevate means to go up, right? Like an elevator takes you up, right? Find the height of the tower. So basically you're looking for x here. If this is the angle, what side is the x? Opposite. Yeah, you're ahead of me there. Opposite. This side down here is the adjacent. So you're going to be doing tangent, right? We're looking for the opposite, so it looks like we're going to be multiplying. Tan 66 times 84. 188.67 meters tall. And usually with a word problem, you try to answer with some kind of a statement. Find the height of the tower. Say 188.67 meters tall is the height of the Calgary Tower. That's pretty tall. Just over 3 feet in a meter, so you know it's approaching 600 feet tall. Okay, the Manitoba Legislative Building. Where's that? Yeah, it's like right there. Right over there. Okay. It's 77 meters tall from the base to the tip of the Golden Boy. Question, is the Golden Boy made out of gold? What's that? Is he actually made out of gold?
Yeah.
Well, I don't know, I'm asking you, I have no idea. I'll have to look it up later and we'll see if he's actually made out of gold. I mean, obviously it wouldn't be pure gold, but hopefully there's some gold in there. Okay, from where you are standing, the angle of elevation to the top of the highest point of the Golden Boy is 30 degrees. How far are you standing from a point directly below the Golden Boy? So, it wants to know how long from here to here. There's my angle. What's this bottom side called? Adjacent. What's the height called? That's the opposite. So again, it's going to be a tangent question. But this time we're looking for the adjacent, so we're going to divide this time, right? So 77 divided by the tangent of 30 degrees is 133.37 meters. Okay, so the question was, how far are you standing from a point directly below the Golden Boy? I am standing 133.37 meters from a point directly below the Golden Boy. Okay. Golden Boy's been there a long time. I don't know if it's appropriate to call him a boy anymore. It's a golden man. Okay, number 4. A ladder that is 9 meters in length leans against the side of a wall. The bottom of the ladder is 1.5 meters from the base of the wall. To determine the measure of the angle between the ladder and the ground. Okay, so we're just finding theta. What's that called, the 1.5? Adjacent. The ladder is the hypotenuse. Which ratio has A and H in it? Cosine. So A over H, we're going to be doing the inverse cosine of 1.5 divided by 9, right? So we'll round it off to 80 degrees. It's a pretty steep angle. May not feel that comfortable to go up the ladder at that angle. Might feel like it. That's the risk with, there's actually a rule. Does anybody know ladder safety? There's a rule for every, like, I think it's for every 4 feet that you go up a wall, you have to come out like 1 foot or something. Otherwise, it's too steep and you can get to the top of the ladder and fall backwards. Yeah. Which is unpleasant. You wouldn't want to fall backwards on a 9 meter tall ladder. It's a 27-foot drop. More than 27 feet. Nobody knows ladder safety? There's a rule. Some ladders even have a little angle thing, like a line. And it says, like, when you put the ladder out, you can see the line, and if it goes, if it's not at least level, that means it's not out far enough. It's a way of telling if it's safe or not. Because you can't tell necessarily when you climb a ladder until you get to the top, whether it's going to go back or not. So, yeah, there's usually a rule for how many feet. I thought it was 1 to 4 or something. Okay, number 5, the distance directly from Winnipeg to Winkler. Where's Winkler? How many of you have been to Winkler? You been there? You been there? No? Just you? Anyone else?
My friend, he went there.
Yeah? Which way is it?
Actually, I just use the GPS.
Oh,
Yeah, so I don't know.
you use a GPS, you don't know whether you're going northeast, south, or west? Just
I think that went.
I think they have a company, right? Chicken.
yeah, they have a lot of big sort of like food processing, agriculture. Yeah.
I think it's 45 minutes from.
Yeah. Yep. Yeah. That direction, there's a lot of big farming businesses out there, and yeah. Once you get outside Winnipeg, you realize how flat Manitoba is, right? You're driving and you look, you're like, as far as you look is flat. That's why it's good at growing stuff. Okay. So the distance directly from Winnipeg to Winkler is 112 kilometers, and the distance from Winnipeg to Morris is 90 kilometers. Morris lies directly east of Winkler, as shown in the diagram. What's the distance between Morris and Winkler? That shows you how much I know. I thought they were the opposite way. I thought Morris was west of Winkler. Okay. This could be wrong. I'm going to look that up later because that's messing with my head. I've been to both places. I'm pretty sure Morris is that way and Winkler's that way, which means it'd be backwards, but okay. So it's just a right triangle, and you want to find the third side. What do I use for that? Yeah, Pythagorean theorem. If I call this x, x squared is going to be 112, the hypotenuse squared, minus 90 squared, and then do the square root. I can neatly do this all in one step in my calculator. And it says that they're about 66.66 kilometers apart from Winkler to Morris. And now, because it's bugging me, I'm quickly going to pull up a map and see if that's even remotely correct, because otherwise it'll drive me crazy all day. I apologize.